Good morning, everyone, and thank you for joining us for one more Living Lab and Data Hub seminar, a space for co-creation to present challenges and educational technologies that promote research in educational innovation. My name is Luis Eduardo Güemes, and I collaborate in the Living Lab and Data Hub of the Institute for the Future of Education at Tecnológico Monterrey. I am very pleased to have the opportunity to join you in this seminar. Today, we'll have a seminar called Emerging Technologies and Concepts for Large Language Models, presented by Sabur Put. Sabur is a PhD student in computer science at Centro de Investigación en Computación del Instituto Politécnico Nacional. He specializes in natural language processing, and his broad research interests are in topics like personality and emotion detection, low resources languages, and question answering. He aspires to create computing solutions with more insights into human behavior. Saul, I give you control of the session.
Thank you very much. I'll share my screen now. So is my screen visible?
Yeah, it's okay.
Okay. So thank you everyone, first of all, for joining. We know that LLMs or large language models have existed for a few years now, but they have always been dependent on a large labeled data for supervised learning. Until GPTs or generative pre-trained transformers were introduced to us, which were very well in zero-shot settings. And we know that the problem of ever-increasing size with LLMs made it very difficult to deploy these models into the real-life settings. And the learning curve of learning about these large language models, deploying them, was huge for beginners or entry-level students. Hence, the purpose of this particular seminar is to reduce that gap and introduce you to the basic concepts of instruction-tuned GPT models, to be very specific, and to quickly make you able to develop these applications using different large language models, and to introduce you to technologies that can help you in developing that. We see the evolutionary tree of these large language models using different technologies, and now we are at the point where a lot of these language models are instruction tuned. I'll explain that later. So we have llamas, alpacas, Google Bard, and GPT-4s available to us. Some of them are freely available, and some of them are paid. Hence, it is important to understand what has brought us to these language models and how we can utilize them in order to solve different problems. So there are base LLMs that generate the next tokens, but instruction-tuned LLMs is something that we are going to talk about in this seminar, and they're different from base LLMs because they take instructions and they follow instructions. And in large language model, NLP language, we call them prompts. So prompts, while talking to ChatGPT, for example, are the instructions that you tell them, and the model is able to generate a response which is very human-like. And these instruction-tuned LLMs are fine-tuned on instructions, and good attempts of following those instructions using reinforcement learning with human feedback will refer to it as RLHF. So, for example, if we have a question like where is the Amazon forest located, the model is not going to generate a few number of tokens that are probable, but will generate a very similar human-like text that the model is trained on or can refer to as. For example, instruction-tuned language models were introduced in InstructGPT, and that is where the revolution of ChatGPT came and was introduced to masses. And in this paper, if we try to understand it, it has divided into 3 steps. In the step 1, we have we collect and demonstrate the data and train the supervised policy. By policy, we mean a large language model in RLHF. And we sample the prompts from our prompt data set, and there is a labeler that demonstrates the desired output behavior that we want from that LLM. So it is all controlled by the labeler in this initial setting. And now that we have supervised data, it is fine-tuned on GPT-3 with supervised learning. So now that we have a supervised policy, in the step 2, we try to create a reward model in RLHF. And in this reward model, again, you get a prompt and several model outputs are sampled and is given to a labeler rank that outputs the best model answer to the worst model answer, and that is how that ranking and reward model is developed. That is in RLHF, and this data is used to train the reward model. And once you have a supervised policy and a reward model, then we have to go into the optimization step, which uses a PPO, which is proximal policy optimization, the state-of-the-art algorithm for RLHF. The same process is followed. You have a prompt that is sampled from the data set, and the policy generates an output using the supervised model that we have. It is passed to the reward model, which calculates the reward and gives us the best output possible for that. And the reward is used to update the policy regularly. And that is how we have been able to improve the entire instruction-tuned GPT process to reduce different behavioral conflicts and things that created ethical issues in large language models as well. So now that we are talking about instructions or prompting, it is also important to understand how we can engineer them. For example, we can use them in a zero-shot setting, and in a zero-shot setting, we just have to create an instruction that recognizes in a natural language text that what it is being asked to do. So for example, if I say, just give me a sentiment that is related to this particular sentence, it should understand what is sentiment and what sentiment is related to that particular sentence, and it should give me a sentence. It should give me a sentiment. And in a few short setting, I have to give a few examples in the prompt in order for the language model to understand how to generate that particular answer. And that few short setting can have examples from 1 to 100, labeled examples from 1 to 100. And the state-of-the-art method right now would be chain of thought prompting, which basically teaches the language model on how to create thoughts while generating the output. And I wouldn't say state-of-the-art because yesterday a new algorithm, which is the tree of thoughts, was released, which outperforms chain of thought. But chain of thought is the fundamental foundational model that is used in the entire presentation that I'm going to give you today. It's included in almost everything these days. So chain of thought unlocks the reasoning potential of large language model. It incorporates intermediate natural language reasoning steps and improves the performance in arithmetic, common sense, and symbolic reasoning tasks. For example, you have a question that says Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Each can has 3 tennis balls. How many tennis balls does he have now? And the way that you're teaching the language model to give an answer is just one line that just give me the answer directly. And it says the answer is 11. But sometimes it is able to give you the correct answer, but most of the times it generates the wrong answer because it is not able to reason. It is just creating a token, which is having the highest probability related to those words that you're giving them. However, if you convert that particular answer generation instruction into a thought, for example, the same question which says Roger has 5 tennis balls, he buys 2 more cans of tennis balls, each can has 3 tennis balls, how many tennis balls does he have now? And the answer is in a form of a thought process that is similar to how human beings think about it. For example, you can say Roger started with 5 balls, 2 cans of 3 tennis balls each is 6 tennis balls, so 5 plus 6 is equal to 11. The answer is 11. And with that type of learning, where you're teaching the model to learn the thinking, you're able to counter these type of scenarios where you have complicated arithmetic problems by giving explanations, for example, as shown in this slide. So let's practice that using OpenAI. So in a zero-shot setting, I'm going to just load the OpenAI library over here. And I'm going to load the LLM with the OpenAI function over here. And I have an instruction that says, what is the sentiment of the following text? I love you. And I'm using the Da Vinci model over here. And it should be noted that Da Vinci model is something that needs fine-tuning and is not an instruction-tuned model, as I explained before. And hence, the answer that is generated to it is so it says, what is the sentiment of the following text? I love you, I love you. So it generates a number of tokens. That makes absolute no sense because it is not able to understand. The reason it is not able to understand is because it needs fine tuning. But instruction tuned language models are able to understand this particular command or instruction in a zero shot setting. So for example, if I run the same command on text Da Vinci, I'm able to get a pretty reasonable response which says the sentiment of the text is positive. Now, there are examples that can work perfectly well in a zero-shot setting, but there will be cases or problems which require you to teach the LLM in a few shot setting. You have to give a few examples in order for the LLM to learn. So for that, I have the same prompt. What is the sentiment of the following text? The sentence says, I love you. I teach it to give me the answer in this particular form where it says label, and the label should be positive. So now when I give it a sentence, it outputs me in exactly the same format. It says label, and the sentence I hate you is negative. And here I can set my parameters. One parameter that you're going to encounter a lot in this particular seminar is temperature, which tells you about the degree of randomness of the responses that is generated. So here I've set it to 0. I don't want any randomness. I just want the same repeated answers again and again. So similarly, let's make it more complicated, and let's give a few examples where I want to extract aspects out of that sentence and then labels of those particular aspects as well. So whatever aspects are mentioned in the sentence and whatever sentiments are available, if both, then it should output both. And I say, what are the emotions and aspects in the following text? And the answer generated to the particular sentence that I'm giving it over here. I went to the restaurant last night, had a terrible experience. The food was awful. The service was even worse. The only saving grace was the waiter, who was very friendly and helpful. So it identifies all the aspects, restaurants, food service, waiters, and the label is generated in exactly that format that I wanted. And the answers are negative, positive, just with a few examples. Now, converting that particular thing into a chain of thought prompting method, I have the same question, but instead of giving answers in a few words, I would like to explain the answer or give reasoning in the answer, which I've done in this case. And hence, the answer that will be generated to the question with one shot of learning would be something like this, which gives reasons. So that particular format of chain of thought prompting is used in many other modules that we are going to see later. So all of this sounds fun, right? Because we are using OpenAI API. But what if you have a data that is too private to be shared with OpenAI or any private language model library? What if you want to connect that language model with an external environment, for example, YouTube or your own personal files, or maybe you want to connect it with Uber to just tell it to book you a ride, or maybe you want to interact with other LLMs. So you want to have a shared LLM space between other LLMs. And what if you want to avoid those language models, or to reduce the size of those language models, or perhaps introduce your own fine-tuned model and create an integration to deploy on the applications, web applications or mobile applications that you want. For all those things, you need to have a particular technology or a framework that allows you to do that, allows you to create that shared space. And that particular technology is LangChain. Now, LangChain is a few months old, is a framework for developing applications, and is powered by language models. And when I say language models, I don't just mean OpenAI. I mean several other language models that are available to us and are coming out every day in the market. So LangChain is developed based on two very important concepts that I'm going to explain. The first concept is that it should be data aware. By data aware, I mean that it should be connected to personal sources of the data. It can be one personal source, it can be several personal sources. Let's say in the example of an institute, Tec de Monterrey, it can have all the surveys of the students in your database so that you can interact with it. And it should be agentic, which means that the language model interaction should be done with the environment. So for example, if I say that open this particular document and extract this particular text out of that, it should be able to do that. It should be able to perform that action using the agents. We'll explain that later in the seminar. So LangChain has 4 very important components. So if you are able to understand and master these components, you will be able to generate applications and deploy them very quickly. And that is the purpose of this seminar as well. You have indexes that contain document loaders, text splitters, vector stores, and retrievers. Document loaders would be used to load the documents from literally anywhere, because we have hundreds of attached document loaders now. The text splitter would split that particular text into chunks, because we can have thousands and thousands of files and you cannot just load them directly. You would have to split them. Then the vector stores would convert those particular chunks into vectors in numerical data, just to make it more easy. And then retrievers who would understand those numerical data and would be able to retrieve information that is relevant to the instruction that we are giving it. So those are for indexes. And then it should have models. So several other language models that are available in Hugging Face, OpenAI, maybe Cohere, which is another alternative to OpenAI. It should have chat models in order to generate chat applications, and it should have text embedding models that are just embeddings that can be taken from different platforms. It should be able to have chains, which is like a prompt template, but built together in a sequential manner. And those templates basically take input from users and return the response from LLM. And then it should have agents, which has 3 components: tools, language models, and agents, the type of agents that you're going to use itself. So the tools will allow you to access or perform functions. The language models are going to give you instructions on what to do. And the agents is the way of behavior that we are going to learn. What type of behaviors agents perform. So initially in models, the first component, you can connect various types of language models with LangChain for production, and LLM integration with LangChain like all these language models that you can see, these are not language models, but perhaps libraries, for example, Hugging Face and OpenAI and Cerebrium AI. So for all types of NLP applications, medical, just general purpose applications, you are able to have access to numerous language models which can interact with each other. So you can use 1, 2, 3, 4, no matter how many number of models that you want to use in generating your application. Then you have chat models and their integration. For example, Anthropic, Azure, OpenAI, who are chat enthusiasts, want to create chat models for various applications. It takes an input and passes it on to an LLM and generates an output and keeps a history of that. Then you have text embedding models available. For example, the ones that you can see in the screen. You can get them from Hugging Face Hub or from Instruct embeddings, from TensorFlow Hub, or wherever you literally want to generate or get embeddings from. You can do that in a few lines of code. Now we also have prompts, and the purpose of prompts is prompt management, optimization, and serialization. And prompt management is a very important component because it happens sometimes that you want to generate a generic template, but you don't know what the input is going to be, because if the input is going to be in the user, so by the user, so whatever the input would be, there has to be a way to convert them into a template so that you can get the precise answer that you want. For example, in this particular example, you can see that the template I'm generating has one variable that is product. And I say, I want you to act as a naming consultant for new companies. What is a good name for a company that makes this particular product? And I don't know what product he's going to mention. So I have this input variable, product, and whatever the particular user is going to say, for example, colorful socks, the LLM should be able to generate a response accordingly. So these prompt templates are very helpful in generating these applications. And you can also have chat prompt templates that have 3 roles associated to them, which is AI, human, and system role. So system basically tells us what the system is thinking while generating that response. The AI role is to generate the response that is generated by the AI, and the human role is to see what human is giving you as an input. And you can generate prompts surrounding that with different variables. For example, in this case, I'm generating a template which says you are a helpful assistant that translates a particular language to the other language. And the input variables are input language, output language. Those can be whatever languages the user gives, French, Spanish, English, or whatever. So let's practice that. Creating prompts. So for that, I am loading up the necessary library set. And over here, I have a prompt. May the subject, which is the variable, be with you. And over here, I'm passing hard coding, basically the subject that I want to put, and the user that is going to the subject that the user is going to give me, and it will generate this chat message, may the force be with you. Just a very simple example of that prompt. But if I have to convert that into a conversational setting, let's say the human prompt that I want to generate is summarize our conversation so far in X amount of words. I'm able to do that by forming it into a human template. So I will run this. And the human message, let's say, is what is the best way of learning programming. And the AI message, which I'm hard coding at this point, but it would be automatic, is whatever the output the AI will generate. And I can convert that into a format where a human message and AI message is given in the conversation, and the word count, which is the variable that I decided, is given over here. And I am able to generate that human message and give it to LLM to summarize whatever has been said before. For example, this entire paragraph would be summarized in 10 words. So that is how you can create different type of prompt templates. There's a lot of variations, so you can dig deep into that. It's pretty interesting, but very useful in order to create generic applications for production. So indexes now are very important, and you have lots and lots of document loaders. You can load these documents from literally anywhere, from clouds, from YouTube, transcripts, your own personal data directly from the URL. And that empowers these language models to basically get the data from anywhere they want, because now you can just directly give a URL and it is able to extract that entire data and then pass it into the language model in order to make it understand what you want. And this is something that as natural language processing engineers, we used to do in probably months, but now you are able to do it in just a few lines of code. Just write like the document loader, give it the link to whatever you want. It can be a PDF, it can be an image, and it is able to process, load, and do whatever you want to do with it. But you will also need text splitters, which divides them into chunks, as I explained before, and you can do that by dividing the chunks into characters, for example, or tokens. You can use whatever library that you like using or you are aware of. For example, NLTK is available, Spacey is available, then TikTok and text splitter is available. So you can divide the text based on whatever library you're familiar of. Then you have vector stores, and a similar story with vector stores. You can convert the text into vectors based using whatever library you're familiar with. It has numerous examples, numerous APIs connected with LangChain, which makes it super fast and super reliable. And then the retriever, you can use whatever retriever class you want to use depending on the use case or the type of application that you're building. We have vector store available, Chroma available, Cognitive available, Azure retrievers available. So whatever you may want is available over here. Let's show you some practical examples for that. And it's very, very powerful because I am able to interact with whatever document or whatever information I have available to me. I'm going to load these chains, retrieval, question answering, OpenAI, and PDF loader, because I'm going to interact with my PDF, my own CV that I'm loading over here. So I'm loading this particular text and I'm splitting it into chunks. So you can see my first page of the CV easily loaded over here, which in itself was a very big problem, loading text from PDF, but it's pretty easy now. So I'm using FAS over here, and I am using OpenAI embeddings, and I'm using FAS index to create a similarity search from the embeddings that I am going to generate. So with the OpenAI embeddings over here, I am asking it to search the entire document for this particular question, which is what skills do Sabur possess, and I want it to return 2 chunks of data. So it gives me 2 chunks of the most probable data that I can use in order to extract the relevant information out of it. And then if I pass that to a question answering chain with the chain type stuff, which I'll explain in my following slides, and I give it the same query: what skills does Sabur possess? And it is able to generate a pretty accurate answer by loading the document. It will take a moment. So Sabur has experience with natural language processing, developing machine learning models, performing statistical analysis, and everything that it was able to get out of my document. It did that and then generated a perfect answer, a human-like answer for that. Pretty cool. Let's go on. So memory as well is a very important component that you can use in your application. The purpose of a memory is to remember the previous conversation, or let's say in examples like you're generating the answer based on the information that is given before. In an application like story generation. So in story generation, you need to understand what happened in the introduction to give a very relevant answer to what happened in the plot, and then the conclusion. So without the understanding of the previous context, you would not be able to do that, and hence memory plays its part over there. And this is a very useful component that is available in LangChain as well. And then the chains themselves, and chains basically are easily reusable components that are being linked together again and again, and you can create as many chains as possible for your applications. A basic example of that can be sequential chains, where each step has a singular input output, and the output of one step is the input of the next step, and the input of the next step is then the output of the next step is then the input of the next step, and so on and so forth. And it has many use cases. For example, transformation of the data, question answering, summarization. And in order to explain it further, think of it as the problem that we have right now with language models, that you have limited tokens that you can pass in them. For example, in general cases, there are just 4,000. You also have, for example, in OpenAI, as much as 32,000 tokens in GPT-4. But in normal language models, it is only able to process somewhat 4,000 tokens, 2,000, 4,000 tokens in order to generate a response. And the first step that you have, there are a number of solutions that you can have in order to solve that problem. If you have thousands and thousands of documents that you want to process the data with. And the first thing is stuffing. And then we have a solution, which is a very powerful solution called MapReduce, and then MapRerank. So stuffing is basic. You have a 4,000 token limit, and your document has no more than 2,000 tokens, just like I showed you in my CV. It has less than 2,000 tokens. I'll give a call to an API, and I'll say that this is my instruction prompt, and this is the context in the document. Please generate a response, and it is able to do that. So you're stuffing all the information that you have into the API call. So that's one way, very basic way. But let's say in a situation where you have 4,000 tokens and your document contains tokens that are double of that, or maybe more than that, 8,000 tokens. Then you will have to chunk the entire text into various texts, and every chunk would go into a command, a chain, which would say generate, okay, this is the chunk. So you would have to take this information and generate a summary out of it. So every chunk will generate a summary and will be concatenated into a list of summaries. And then those list of summaries, which are now less than 4,000 tokens, will be used in order to create a final summary. And that is the chain of command that you are following in order to reduce the text and still semantically preserve the information that is given in the document. So that is a very useful way. And then we have MapRerank, which follows the same steps, but the difference over here is that you're generating the answers in a question answering format. So you have the document, which is 8,000 tokens, and the limit is 4,000 tokens. And you would say that this is the particular chunk of data, and this is my question. And what is the probability or percentage that this the answer that you are generating out of this context is the right answer? And a score will be associated to that. For example, 10%, 30%. Oh, I think this answer is 40% correct. And from the text that is the most relevant, obviously the score would be the highest. And hence the final answer would be the one with the highest score. So you rank the answers generated from all the documents in a question answering setting, and that is MapRerank method. Also a very useful method. Let's practice that. So for example, in this case, I have two documents. One document is a small document. Over here, you can see it's a very small document, less than 2000 tokens, perhaps. And then I have a very large document over here, which has a lot of text. And let's first load them using unstructured file loader, one of the type of loaders that we have in LangChain. Then I will divide them, split them, and I want to see the summary of how many tokens are available. So I have one document, and in case of several documents, it will print out the number of documents that you will have, and then the number of words that you have in that document. And this is the preview of that document so that you know what you are dealing with. And then for the large document, you can see that I have 13,000 tokens, which is much more than the limit of 4,000 tokens. So I'll call the language model, and I have called a summarization chain that is also a pre-built template in LangChain. So I just load that summarization chain, and I am using the stuffing method. So I'm trying to stuff everything over here. And this particular parameter verbose true basically tells you what the language model is thinking while generating the answer. It's pretty cool. So you would load that and you would run the chain, and you can see that the language model says write a concise summary of the following, and it generates a summary using all the data that is available in the document. So the chain is finished, and this is the final summary that I have got. Now, if I try to do that with the large document, obviously I get an error which says that the model's maximum context length is 4097 tokens. So now let's change that using MapReduce method that we have learned. So I load this same summarization chain available to me, run it on the small document, and I get the summary of that. But now I want to run it for the large document, and for that, first I have to chunk it up into different portions. So I'm putting a chunk size of 400, and I don't want any chunk overlap, n-gram overlap on that. So I load that. I'll use a text splitter to split that document, and then I will see the summary. I have now 188 documents that I generated out of that single document. And now that I run it, it will be able to generate a concise summary of everything because of the chaining method that I have performed right now. So it will take a moment. So as you can see over here, it is saying write a concise summary of the following. It takes a chunk, writes a summary. Then it says write a concise summary of the following, does the same, so and so forth for the entire document. And then in the end, I have the final summary of the entire document that I want. Pretty cool. Let's go on to the next part. And that is agents. So agents allows us to interact with the tools, and that can be any tools, and it allows us to give them the command or basically tell them what to do with it. For example, I could just write open the browser, and my browser will open, and then I can say go to that particular link, and that link will be open, and then I say extract all the text out of that link. The text will be extracted. Then I can say, okay, I want this particular information from the text, and that will be done. So all these steps that would take perhaps months to generate an application are now done with just a couple of lines of code. So there are numerous types of agent types for conversations, for asking it to the search, or having a conversation with the React doc store. In this presentation, I'm just going to be demonstrating the zero-shot React description, which basically uses the React framework, is one of the agent type frameworks, to determine which tool I have to use based on the description of that particular tool. For example, I have a tool that is a calculator, and its description is that it helps in calculation. And if I have a command or a prompt that says 2 plus 2 is equal, what is 2 plus 2? It should be able to call calculator and give it a command to perform that particular function. So it takes an input and gives an output in a zero-shot setting. And React is a framework that is very popular right now. There are a number of frameworks, but React is one of them. It's very popular. And it is basically a combination of reason plus action. And reasoning is a huge game changer in that, because just action basically makes the language model hallucinate a lot. And the way that it works is that you generate a reasoning and you pass it into a language model. Language model is able to send an instruction to the environment. The environment will generate an observation, pass it back to the language model, and this particular loop continues as until your final answer is calculated, which is decided by the language model as well, that what is the final answer. Once it is very confident that this is the final answer, it is able to generate that. So normally in history, you would see in question answering setting, for example, we have an example from Hotspot question answering, which is one of the question answering data set. And I have a question that says, aside from the Apple remote, what other devices can control the program Apple remote was originally designed to interact with? And the standard answer generated by LLM is iPod, obviously incorrect. But if I ask it to reason, just reason, it says, let's think about that step by step. And Apple remote was originally designed to interact with Apple TV. Apple TV can be controlled by iPhone, iPad, and iPod Touch. So the answer is iPhone, iPad, and iPod Touch, which is, again, a wrong answer. So if I give it to an act-only module, which does not think, only performs actions, it is able to take that particular command and it is able to pass it to the tool which is relevant, which is the search engine, pass Apple remote to it, get a context, from that context generate another search function until it has the final answer. And as you can see in this case, it is not able to generate a final answer because the question that we have is complicated. So that is another example of an act-only approach to deal with agents. But as you can see that it hallucinates a lot and it does not create the particular outcome that we want. But if you combine reasoning and acting together, that's game changing. It still hallucinates, but the performance is much better. So for example, in this case, I'm creating a thought which says, I need to search Apple remote and find the program it was originally designed to interact with. So first it will search Apple remote and it will generate an observation out of it. Then it will generate a thought based on that observation, that Apple remote was originally designed to control the front row media center program. I need to search front row next and find what other devices it can control it. So now it's searching front row and it is generating an observation that I could not find front row. So similar to front row would be front row seat to earth, and so forth. It continues until you find something similar. So now when you're searching front row software, it is able to generate, oh, the front row is a discontinued media center software. You use that particular information, generate a thought until you have the final answer, which is the keyword function keys, which is the correct answer to that. So that is another example to React. We'll not go into that. I think it's better just to practice. Let's see how we can do that. So I'm going to load from LangChain again the tools that I want to use. I'll define that, and then I'll initialize the agent, and I'm using OpenAI just to demonstrate. So I load by LLM, and the tools that I'm using over here is SERP API, which is one of the APIs that you can use to interact with searches. And then I have LLM math. So now I have search available, something very similar to Google. I can get real life examples out of it, current examples out of it. And then I have a tool that deals with math, and I'm loading both tools. I can use them simultaneously in one chain. I can demonstrate them separately. So over here, I'm using a zero-shot React description. As easy as that, just define your agent and verbose is equal to true, so that we can see what is happening with the LangChain. So I would just ask it my name, who is Sabur Bhatt, and I'll run it. And let's see what is the thought process. So it says I need to find who Sabur Bhatt is, and I have to perform an action, which is search, and the input of that action would be my name, of course. And the observation that it made by extracting the text out of the SERP API is that Sabur Bhatt is a student in Instituto Politécnico Nacional with an email this and the homepage this. So now I know the final answer. The agent is very confident that I know the final answer, and hence it prints out the final answer, which is Sabur Bhatt is a researcher. Okay, so let's do that with another example. So another example would be, okay, how many even numbers in 100? So it's a problem that it is a math related problem. So it now knows that it has to call the calculator. It says, I need to count the even numbers. The action is calculator. Action input is 100, or answer is 100. Now I need to divide the answer by 2. Calculator, it performs all the actions and thoughts and all that process, and then generates the final answer, which is 50. So there are 50 even numbers in 100. It knows how to think. It knows how to perform an action, and that is a very, very powerful thing that you have at your disposal, and you can make numerous applications out of that. And a lot of people, if you'll go and you see what they have been doing with this, they have been generating the whole pipeline where everything is automatic. For example, I can say, go open YouTube, and in YouTube search Tech de Monterrey, and in Tech de Monterrey find this video, extract it. From that extraction, find me this information, and it is all able to do with just one command, as I have shown you, by just adding multiple tools to the agent and writing a prompt very clearly, maybe perhaps in a zero-shot setting if possible, maybe in a few shot settings. So that is what you can do with it. And the best thing about LangChain is that you can deploy it very, very quickly with a few number of lines. For example, you can go over here in the deployment section, and you can deploy whatever language model or whatever pipeline that you are able to generate with Streamlit, Gradio on Hugging Face. You have Beam, Versal, Fly.io, all these number of deployment tools that you can use in order to create very fancy applications, web APIs, and everything. So that's pretty useful. And then if you want to look into other agents, you can also look into that. You can look into autonomous agents. Different type of agents are available. You can go and check that. So in this presentation, I only gave you the idea of what React is, but of course there are numerous agents, and the way they work is very different. So perhaps you would want to choose what suits you the best as well. So that's pretty much it. There are also a number of tools, the other tools that are being generated very rapidly. For example, Hugging Face has its own tool, which is called Transformers Agent. You can look into that. A little similar to LangChain, but LangChain is more descriptive and is developing very, very fast. So that's it with the seminar. If you want to find me, you can find me over here. And now I'll open the room for questions if you want. Thank you.
Thank you very much, Sabur. If anyone has any questions, you can send them through the chat, or you can open your microphone and raise your hand.
Yes, Louis, I think, has his hand raised.
Well, I think there's no questions from the audience.
I think there are a couple of hands raised by Louis and no, I think just no one.
No, I think those were the animations for applauses.
Oh, okay.
Well, I think there is no questions from the audience, so well, we're going to close the session. Thank you very much, Sabur, for your presentation. I'm going to share a little bit the screen. So I want to invite you to join us in our next seminar on June the 9th with the EdTech Musa, where they're going to talk us about microlearning through WhatsApp. Also, you can follow us in our YouTube channel, where you can find all our past seminars, and where we are also uploading this very seminar later today. And it is very important if you can help us answering this survey. I also send the link through the chat, so it would be very helpful if you help us. This can help us to improve these seminars. So if there is no questions from the audience, thank you very much, Sabur, for joining us today. This is a very important and a very interesting topic in these days. So thank you very much for joining us.
Thank you for inviting me. Thank you.
Thank you very much, and have a nice day. I will close the Zoom session. Goodbye, everyone.